Okay, so you are going to start ionic equilibria, uh, acid-base equilibria basically. In this chapter, we will be discussing about acids and bases, or and also some sort of concept of equilibrium, like from the previous units. Like I'm talking about Kc and Kp calculation. Equilibrium constant. So starting from acid, we are familiar with this term acid. Acid is a proton donor. According to the Lowry-Bronsted theory, acid is a proton donor. Proton means H positive ions. It's not a proton that is present in the nucleus of an atom. It's something else. Why we are calling this as a proton? Because in this, like I can say on this hydrogen, we have a positive charge. On this hydrogen, we have a positive charge. Generally, the proton number for hydrogen is 1. So it has only one proton, one electron and zero neutron. But when we will be having H positive, so it's mean that positive means loss of electron. Positive means loss of electron. So loss of electron means that right now it has only one proton. So that's why it is known as proton. So whenever in this chapter we will be saying that it's a proton donor. So we are talking about the H positive ion, not the proton which is present in the nucleus of an atom. And then, so all acid contain proton. We can define acid in multiple ways, like according to like I can say Lewis theory. He says that acid is a substance which is going to accept a lone pair of electron. Like if you remember when we were discussing chemical bonding, so we have discussed about dative covalent bond. What was going on in a dative covalent bond when ammonia was reacting with H positive ions? Since ammonia has a lone pair of electron, like on the nitrogen has one lone pair of electron. So ammonia is giving its lone pair of electron to the H positive ion. So ammonia is going to give its lone pair of electrons. Some ammonia is a base. So we can also discuss acid and base on the basis of lone pair of electron. So sometimes we discuss acid and base on the basis of lone pair, and sometimes we discuss acid and base on the basis of proton donor and proton acceptor. So by the way, right now we are discussing on the basis of proton. So acid is a proton donor. Uh, like let's say I have dissolved acid in water, so it's going to give its proton to this water. Like initially it was H2O and right now it's H3O positive. It has accepted a proton from this HCl. So that's why HCl is an acid. And in this equation, water is acting as a base. We know that water has an amphoteric nature. What is amphoteric? It has a dual nature. When it would be reacting with an acid, it would be having as a base, or when it would be reacting with a base, so it would be behaving as an acid. It has a dual nature because it has both ions, H positive ion and OH negative ion. So, so this is an equation in which we are going to show that how acid is behaving as an acid. Yeah, HCl is behaving as an acid. So uh, then we have this is this is another example of acid. This is an example of acid. This is an example of acid in which H2SO4 will be giving its proton just like that. Then we have another example, HNO3, it's also an acid, it's a nitric acid, it would be giving its H positive ion like that. Then we have H3PO4, it's a phosphoric acid, it's also giving its proton just like that. So the thing is that all the acids are going to give its proton. That's mandatory, right? So then we have types of acid. Like we have strong acid, then we have weak acid, then we have concentrated acid, then we have dilute acid. So first of all, what is a strong acid? So a strong acid is the one which completely ionizes. Strong acid is the one which completely ionizes, or I can say dissociate. Let's say if some, like let's say if I have HCl and I have taken 100 molecules of HCl, so out of 100, 98 molecules are going to give their H positive ions, like almost it is dissociated. So it would be called as a stronger acid. The formula is same, concept is same, everything is same. It's proton donor, it's sour in taste, soluble in water, good conductor of electricity. It will turn blue litmus into red. It's a good conductor. Like it's a liquid at room temperature. It's colorless. It's harmful. It's everything is the same. But the thing is that what is the difference between a strong acid and a weak acid? Is only on the basis of how much they are going to give their protons. If they are going to give their protons more in a solution, so we will call that it's a stronger acid. And if in case the acid has 100 molecule and out of 100 it's going to give only 10 molecules, like I can say only out of 100 only 10 molecules are going to give their H positive ion, so I can say it would be weaker acid. It would be what? Weaker acid. So most of the students ask, sir, how can we identify after looking at the formula directly whether this is a stronger acid or a weaker acid? So the answer is we can't identify. We can't identify after looking at the formula, right? Because it's total experimental work until or unless some other information is provided, like I'm talking about Ka, dissociation constant for acid. Because on the basis of Ka we can decide whether the acid is stronger and whether the acid is weaker on the basis of Ka, right? So, but generally we tell to the students that if you have memorized three formulae like HCl, H2SO4 and HNO3, since they are stronger acids, other than this, all would be weaker acid. Other than this, we have three: hydrochloric acid, nitric acid, and then phosphoric acid. So other than these three, all would be weaker acid. That's it. Okay. So so in short, what's the difference between a strong acid and weak acid? Strong acid means which completely ionizes, and weak acid means which does not fully ionizes. It is also known as partially ionizes. Partially means does not fully. It may be 1%, it may be 2%, it may be 10%, it may be 5%, it may be 15%, but not fully ionizes. Of course, for the weaker acid, we can say that the pH will be near to 7. We know that 7 is the neutral pH, right? So if the pH is 6, 5, 4.5, it means that this would be weaker acid. It's near to the neutral. It's near to the neutral. And when it's far from neutral, like 1, like 2, like 3, so I can say that this would be stronger acid. Okay, this would be stronger acid. So like we can identify by dipping the pH meter into the solution. Of course, this is a total experimental work, but if you don't have such things, so the only way is to have that. First of all, we have to memorize the stronger acids, and we can expect that other than these acids would be weaker acids, or until the examiner would be giving you the information regarding the Ka, dissociation constant for acid, and also the pKa. We have also the term pKa. We will be discussing later on what's the difference between Ka and pKa. So this is all about strong and weak acid. Then we have how can we determine the strength of acid, like how much the acid. You are saying that HCl and H2SO4 both acids are stronger. Of course, they wouldn't be having the same strength. HCl is something else, H2SO4 is something else. So the question is that what's the difference in strength of these two acids? which is more stronger and which is less stronger. Even if this is even if there is a very minimum difference, but there is. So we have to identify that difference. So the only one way is to determine the pH of a particular solution. So we will be finding out the pH of that solution. After finding out the pH, we can decide whether the acid is stronger, like more stronger, and whether the acid is less stronger. So what's the formula for pH? pH is a measure of the concentration of H positive. Why? Why this is so? Why we are going to measure the concentration of H positive ions? You know why? Because which ion is responsible for the acidity of an acid? So the answer is H positive ion. Only H positive ion is responsible. So we will be determining the concentration of H positive ions. So that is known as pH. What's the relationship between pH and concentration of H positive ions? So the answer is inversely proportional. Negative log. Negative log means that it's inversely proportional. Okay. Inversely proportional means that when the concentration of H positive ion would be higher, so the pH would be lower. And when the concentration of H positive ion would be lower, so the pH of the solution would be higher. Higher means what? It would be near to 7. It would be like higher means what? Let's say for a comparison, I'm saying that I have two solutions. The first solution has a pH 1 and second solution has a pH 6. 6 is higher. It's near to 7, means that I can predict the concentration of H positive ion in that solution, since we know that the pH is higher. So when the pH is higher, so I can say that the concentration of H positive ion would be lower. And when the concentration of H positive ion would be lower, so the acid would be weaker. But if the pH is 1, means that the concentration of H positive ion would be higher when the concentration is higher. So I can say that the pH would be like lower, right? So by the way, it's inversely proportional to each other. So it's the relation. We have to know this relation because examiner would be giving you the concentration of H positive ion and will be asking about the pH and vice versa. Sometime he will be giving you the pH of the solution and he will be asking about the concentration of H positive ion. Like in this question, I have asked to find out the pH of 0.1 mole per decimeter cube HCl solution. So HCl is going to give you H positive ion and Cl negative ion. I can say that the relation is 1 is to 1, the mole ratio is 1 is to 1, or I can say 1 mole of HCl can give 1 mole of H positive ion. Since the ratio is 1 is to 1, and by the way, this is a strong acid. I have written, I have made a, I have made a single arrow. This is also the way to find out the strength of acid. If you can see the double arrow, which will be showing about the equilibrium. If you can see the double arrow, so I can say that it would be weaker acid. If you can see single arrow, so I can say that this would be a stronger acid. So it's only in the case of a stronger acid you can take the mole ratio between the acid and the concentration of H positive ion. I'm repeating, in only this case, like I'm talking about stronger acid, you can take the mole ratio because we know that we are 100% sure we we are 100% sure that all of the acid has been converted into the H positive ion. So that's why we can take a mole ratio. But in the case of weaker acid, since we are not sure that all of the acid has been dissociated or not, so I can't take the mole ratio. So that's why it's a concept that whenever you will see stronger acid, so we can take a mole ratio. And that's why we are taking a mole ratio between acid and the concentration of H positive ion. And when in that case, when we will be dealing with the weaker acid, so we can't take a mole ratio. That's the concept. That's the concept. It's an important concept, right? So um, right now I'm taking a mole ratio, so that's why I can say that it's a stronger acid. So since I gave you the concentration of HCl, that is 0.1, so the mole ratio is also 1:1, that is this, right? So I can say that it would be the concentration of H positive as well. I'm going to put it in this formula. I'm going to get the pH. I'm going to get the pH. That is one. Simple. In this way, you can find out the pH of any of the solution when the concentration of acid is given to you. It's very easy. It's very easy. Okay. Okay. Then you can see this one. Then you can see this one. Find the pH of 0.1 mole per decimeter cube H2SO4. Since I gave you the concentration of acid, not the H positive ion, so you have to put the mole ratio to get the concentration of H positive ion. Since the ratio is 1:2, if I give you the concentration of 0.1, so the concentration of H positive would be 0.2, right? You can take a mole ratio in this way as well. Uh, then after putting the concentration, then you can get the pH of the solution, that is going to be 0.699, and that's it. Okay, so that's all about how you will be finding out the pH if the concentration of H positive ion is given to you. Or, or, what do you think about that? What's the answer for this question? Yes? You can try this. Find the pH of 0.1 mole per dm cube H3PO4. Yes. What's the answer for this one? Yep.
Can I just copy down the um
Yes.
pH of 0.1 mole DM3 or
Yes. Yes.
H2SO4
Yes. Yeah,
because I
exactly.
can't see it. Thank you. Yeah, okay, I'm done. You can show me the question.
Okay. So you can see this one, H3PO4.
Yeah, yeah, I can.
It's very easy. Like you can take a mole ratio just like that.
Yeah,
Like in
I'm just doing
H2SO4,
it.
yeah. Like in H2SO4, we took a mole ratio between H2SO4 and H positive ions. That's what that was 1 is to 2, I think so. Yeah, 1 is to 2.
Yeah.
So in the same way,
So for this one, would the ionic equation be H3PO4, H plus plus HTP H2PO4 minus?
like you can do in this way, we know that this is triprotic acid. So I can
Yeah,
say that it's going to give you 3 moles of H positive ion. So I can say that the mole ratio between H3PO4 and H positive would be 1 is to 3. So if it is 1 is to 3, so just we
yeah.
can do just like an H2SO4.
Oh, okay, fine.
Yeah, like that.
Okay, okay, that makes sense.
So it's always the same. Whenever you can see this one, like this question, so always the equation you like it equation should be in your mind, like in this acid, how many H positive ions we are going to have. So on the basis of H positive ions, so like we can say that we can take a mole ratio just like that to get the concentration of H positive ion, then we have to put it in the formula that is pH is equal to the negative log of H positive ions, and then you can go for the pH. It's very easy. Okay.
Yeah.
Okay. And then, uh, okay, what if the pH is given to you? Like I'm going to do reverse calculation. What if the pH is given to you and he is asking to find out the concentration of H positive ion. Find out the concentration of H positive ion. Just like that. Serious question. I'm asking the concentration of HCl and I have given you the pH. That is 1 is to 1. 1 is to 1. So then how you will be doing this question? Just to have an idea. Then I'm going to tell you.
Would we change? Would we reverse the log?
Okay. Like you're talking about anti-log, right?
Yeah.
Okay.
Um, and then probably have the ionic equation out, and then what ratio we get, we just kind of divided by that, if that makes sense.
Okay. Okay. So that, am I correct? See this? Okay. Is this correct?
Yeah, I'm just copying it down.
Okay. Uh, okay. So basically what I did, I know the pH that is 1.1. Uh, so I have put 1.1. Then what I did, I'm going to put I'm going to uh, press the shift button and then log. It's going to give you anti-log. Then I'm going to take an anti-log of negative 1.1. It's going to give you the concentration of H positive ions. So we can do reverse calculation as well. Depends what the examiner is asking. Okay, right?
Yeah.
Yes. Okay. So then what about this one? What about this one? I gave you the pH that is 2.4. I'm asking the concentration of H2SO4. So of course, after applying the formula, we can find out the concentration of H positive ion. Then we have to take a mole ratio between H positive and H2SO4 since the mole ratio is 1:2. Then after solving, you can get a concentration of H2SO4, right?
Yeah.
So what's the answer? Then I'm going to
One
tell you.
second. Is it going to be 0.003?
0.003. So what you did, first of all, you found the concentration of H positive ion after applying the formula, that is pH is equal to the negative log of H positive ion. And then about that, then we have put the concentration over there. Okay. Because the mole ratio is 1:2 and that's going to be X, then what you did, cross multiplied, and then you got the concentration of H2SO4 like that. Am I correct?
Yeah.
Yeah. Okay. Okay, 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 okay. Or yeah, that's it. So it's all about to find out the pH of unknown solution when the concentration is given, or like vice versa when the pH is vice versa when the pH is given. So it's very easy to find out the concentration of anything, to find out the pH of anything, since we know the relation, right? Or I can say that or yes. Okay. Then we must know about that. It's known as auto dissociation of water. It's a very important topic. It's a very important topic because sometime uh, he will be giving you he will be giving you the concentration of a base, and he will be asking to find out the pH. and he will be asking to find out the pH, right? So how can we handle these type of questions? So how can we handle these type of questions? So remember, uh, we know that this is water, and since we know that water is a good conductor of electricity, I'm talking about tap water. I'm not talking about distilled water. I'm talking about tap water. So by the way, whether it's a tap water, whether it's a distilled water, both are conductor. The thing is that both are conductors. When I would be asking why they are conductor, so they have a free ions. So where the ions are coming from? Where the ions are coming from? So that's why I'm going to say that it's a good conductor, or I'm saying that it's a conductor. So it's all about the movement of ions. So the thing is that water in its solution, in its liquid form, auto dissociates to give H positive ion and OH negative ion. Auto. You are not supposed to do anything. It's automatic. It's automatic. So uh, when you will be putting the conductivity meter into water, so you will see it would be giving you conductivity. It has a free ions. So the concept is that at a room temperature, you will see there would be H positive ion and you will see there would be OH negative ions. Now, if you are thinking how much H positive ion, how much OH negative ion, so the answer is that, it's fixed. It's fixed. The number that I'm going to tell you, it's already fixed. So the concentration of H positive ion is going to be 1 exponent minus 7. You can see over there. 1 exponent minus 7, right? Or so the same concentration of OH negative ion, that is 1 exponent minus 7. That's why the pH is 7. They are going to cancel each other. They are having the same amount in water. That's why the pH is 7. So it's fixed. You have to know this. It's fixed. So the overall value would be 1 exponent minus 14. So the sum of H positive and the sum of OH negative would be 1 exponent minus 14. Okay. So I'm going to take negative log of this one, this one, this one. I'm going to take negative log. So after taking a negative log, so the negative log of H positive ion is pH. The negative log of OH negative ion is POH. The negative log of this number is 14. So I got the relation pH plus POH is equal to 14. This is the relationship that we are supposed to use. Or else, if you remember when we used to say about the Kc value, so the Kc is equal to the concentration of product divided by the concentration of reactant, right? So the concentration of product divided by the concentration of reactant. So this is your product, this is your reactant, product upon reactant. And we knew that we are not supposed to, we are not supposed to put the liquid in the Kc expression. We are not supposed to put the liquid in the Kc expression. So what I did like that. Kc multiplied by H2O, it's gonna be Kw. Kw is equal to H positive ion into OH negative ion. This is another relation that you are supposed to know. It's very useful relation. How? When we will be using this relation, you can see this question. This is a very good question to learn this concept. The importance of this relation. I gave you the concentration of OH. NaOH is going to give you Na plus and OH minus. So if this is 0.1, this is 0.1. I gave you OH minus. You can't apply this formula directly because this is going to be pH negative log of H positive ions. So before going to put this formula, you need to find out the concentration of H positive ions. So I took this relation. Since we know that the value for the Kw, it's gonna be 1 exponent minus 14. I put over there. I know H minus, that is 0.1, and I have to find out the concentration of H positive ion. I did this one. Now I know the concentration of H positive ion, and I can put it in this expression. That is going to be the simple one. pH is equal to the negative log of H positive ions. That's why you have to see the question, whether the concentration of acid is given, whether the concentration of a base is given. If the concentration of acid is given, so you can directly apply this formula. But if like that, concentration of acid is not given, so you have to first find out the concentration of H positive ion, then you can apply the concept. Are you getting my point, what I'm saying?
Yeah.
Okay, so in this way, like we will be, I can say, applying this, what can I say, concept. So you have to know at that time what you are doing and what you are supposed to do, whether the concentration of acid is given and whether the concentration of base is given. So it's important, right? Okay.
Yeah.
Okay, and then, by the way, this is the constant value of Kw at room
Mm-hmm.
temperature. This is the constant value for Kw at room temperature. Room temperature. What if, what if I am going to increase the temperature? What if I am going to increase the temperature? Since water, like dissociation of water is endothermic, since dissociation of water is endothermic, because bond is going to break down, that's why it's positive. So if we will be increasing the temperature, if we will be increasing the temperature, so what do you think, what will be the, what will be the direction of reaction? What will be the direction of reaction? Forward or backward? What do you think? Forward or backward after increasing the temperature? It's an old concept. It's an old concept, right? I'm talking about old concept means that when we used to discuss about the Lee-Chatelier principle, when we
Yeah.
used to discuss the Lee-Chatelier. So Lee-Chatelier says that
So it
when the
would
temperature,
move forward in the
yeah,
endothermic direction.
exactly. So I can say that uh, the reaction will be moving in a forward direction, isn't it? So the
Yeah.
reaction will be moving in a forward direction.
Forward.
So when the reaction will be moving in a forward direction, I will be getting the more product. When I will be getting the more product, when I will be getting the more product, so the value for the Kw will increase. So the value for the Kw will increase. When the value for the Kw will increase, when the value for the Kw will increase, so remember, like I can say, when the temperature increases, when the temperature increases, so means that the value for the Kw will increase. That's the concept. Okay.
Yeah.
It's all about the temperature. It's temperature dependent value. It's temperature dependent value. That's the concept that we need to know. It's a temperature dependent value, right? Okay.
Mm-hmm.
Okay. Okay. So and after this, I can say so On the basis of the question, we can determine like should we apply this concept or not. So of course, since the concentration of OH negative is given to you and we have to apply the pH formula, we should know the concentration of H positive ion. So ultimately, we will have to apply this relation. Okay.
Yeah.
Yeah.
So we only apply it when we have like a negative element, like an atom,
Like
like
when the
OH.
concentration of base is given,
Yeah.
but they are asking to find out the pH, then we are supposed to apply this.
Okay. Okay.
Yeah.